Assalamu alaikum students, my name is Faisal and today we are going to proceed towards the completion of our next area, which is related to the numerical problems of the chapter 6, and the name of the chapter is Mechanical Properties of Matter. So without wasting any time, I'm proceeding towards the inception of that particular area, which is material or important or significant in terms of your examination. So without wasting any time, I'm going to read the first interrogative context or the situation or the scenario as established by the examiner. And that particular situation relates or pertains to numerical 6.1. And the situation or the statement is a spring is stretched 20 millimeter by a load of 40 Newton. So I'm considering a vertical mass spring system. There are two types of systems, first one is horizontal mass spring system, and I'm considering for the sake of your convenience, for the sake of your feasibility, a particular vertical mass spring system. So there is a spring. One terminal end of the spring is attached with a fixed end, and on the other terminal end of the spring, the examiner said you have to hang a particular load of weight 40 Newton, or the gravitational pull or the magnitude of the gravitational influence on the load on the object is 40 Newton. So magnitude of the weight of the load is 40 Newton. Or you can say that the gravitational pull, the magnitude of the gravitational influence acting on the object which is hanging on the second terminal end of the vertical mass spring system is approximately 40 Newton. So I have put the spring is stretched 20 millimeter by a load. So there is a change in length of approximately there is a change in length by a load of 40 Newton, which is denoted by the symbol x1, and the magnitude of the change in length is approximately the dimension which is changing is length. So that is, if length is changing, so that particular kind of deformation is known as linear or axial deformation. So the magnitude is 20 millimeter, and in SI system, the unit of length is not millimeter. So in SI system, the unit of length is meter. So to convert millimeter into meter, we have to replace the value of the prefix, which is milli, and the value is 1 milli is equal to 10 to the power minus 3. So I have put on the right hand side of the Excel sheet the standard reference as well. And the standard reference is 1 milli is equal to 10 to the power minus 3. And by substituting the value of milli in 20 millimeter, the 20 millimeter is converted into meters, and its value is approximately 0.02. So the weight of the first object, which is hanging on the second terminal end of the vertical mass spring system, is approximately 40 Newton. So what did the examiner ask? The examiner said, calculate the value of spring constant. So we have to calculate the magnitude of spring constant, and spring constant is a constant, and that constant depends upon the nature of the spring. If spring is not changing, so in approximately almost all of the cases, the magnitude of spring constant will not be changed if the spring is not changing, because it is approximately dependent on the nature of the spring. So to calculate the magnitude of the spring constant, there is a particular relationship which is computed or derived or calculated by a particular scientist, and that particular mathematical relationship is Hooke's law. As there are two pieces of situation, or there are two particular scenarios, or there are two specific scenarios in that situation. First one, there is a spring, a load is hanged on the second terminal end of the spring, and its weight is approximately 40 Newton. So the gravitational pull, which is acting downwards, behaves as a deforming force, is approximately 40 Newton, and the change in length is approximately 20 millimeter, which in meters is equivalent to 0.02. So by using the mathematical relationship, as the spring is same, so using Hooke's law, the value of spring constant is calculated as follows. F is equal to K multiplied by X. And that F is restoring force, which is established by the particles in response to external applied force, which is the gravitational force in that particular context. And the gravitational force is behaving as a deforming force in this situation as well. You guys are very smart as compared to me. So, and as in the case, the weight exerted on the spring appears in the form of weight. So applied force, external net force, is equal to gravitational force acting on the spring due to the load, which is equal to the weight of the load. And in this situation, the change in length is denoted by the symbol x1, because that is the situation number 1. So the change in length x is denoted by x1 to differentiate that change in length from the second situation, which is x2. So using formula and relationship, so by substituting these variables, which are specific to the situation number 1 in the formula which I have written above, which is F is equivalent to K multiplied by X, the formula will become W1, weight of the first object, is equal to K, that is spring constant multiplied by change in length of the first object, or sorry, change in length in the first situation, change in length of the spring in the first situation. So K is written on the right hand side, multiplied by change in length. So change in length, which is multiplying on the right hand side. When I shift that change in length towards the the left hand side of the relationship, it will divide on the left hand side. So K is equal to, by shuffling change in length, I'll get the formula. Spring constant is equal to weight of the object divided by change in length. By putting values, the magnitude of the weight of the object is approximately 40 Newton. Here I have written in the cell address number C30, and the change in length is approximately 0.02 meters. So by putting values, I have got 40 Newton, 40 divided by 0.02 meters. 0.02 is written in the cell of address T11. So the magnitude of the spring constant is 2000, and the SI system, in SI system, the units of the spring constant is Newton per meter. And you know it, I have calculated in the previous class. And how did I calculate in the previous class? That K is equivalent to F over X. F is the applied net force, or F is the restoring force actually, which appears due to the restoring capacity of the particles of the medium in response to the external deforming force. And you know that restoring force depends upon the change in length, and change in length depends upon the external applied force, and that particular area I have discussed in the flow. So, and K is equal to F over X. The SI system, in SI system, the units of applied net force or the restoring force or any kind of force is Newton. So Newton is in the numerator, and change in length in the denominator, or the SI, in SI system, the units of change in length or any kind of length is meters. So meter will be your denominator, and Newton is your numerator. So in SI system, the unit of spring constant will be Newton per meter. Now, what did the examiner ask, or what did the examiner describe in the second situation? The second situation is if an object, the spring is same. Spring is same. First of all, I'm absolutely saying that the spring is same. So if the spring is same, spring constant will never change. So if spring constant will never change, so the change will be induced in two particular kind of variables. And what are these two variables? These are the restoring force established by the particles in response to the external applied force or the gravitational pull or the weight of the object. And the second one is the change in length in the spring. So the examiner said if an object causes an extension of 16 millimeter, means examiner has replaced another object with the previous object of 40 Newton. And now, due to the second object, the overall change in length or overall change in the magnitude of length of the spring is approximately 16 millimeter. Now, what will be the change in length in the first case? The change in length in the first case is 20 millimeter, and in the second case, the change in length is lesser as compared to the first case. So if the change in length is lesser as compared to the first case, it means that the load which I have hanged in the second case will be lesser or more. Kindly answer. You said as sir, in the second case, the change in length is lesser. So the weight which we hanged in the second case is lesser as compared to the first case. So the magnitude of the weight should be, the value which you will drive in the second case should be less as compared to the first one. So your answer will be lesser than 40 Newton. If any student drives the answer which is greater than the 40 Newton, so it's his or her answer shall be wrong. Definitely wrong. Okay. So as in the second case, the weight of the object, so spring constant is same, which is 2000 Newton per meter, as you have tracked earlier, which is 2000 Newton per meter. And in the second case, as the spring is same, so using the relationship, F is equal to K multiplied by X. As in the second case, the weight exerted on the spring appears in the form of weight. So that particular statement is copy paste from the previous slide. That the second case, that the external applied force exerted due to the gravitational pull appears in the form of weight. So F is equivalent to gravitational force on the surface is equivalent to W2, which is the weight of the second object. And the change in length in the second situation is X2. So the formula will become, by substituting a symbol, and as contingent to the second situation or the second case. The formula will become W2 is equal to spring constant multiplied by change in length. In the second case, by putting values, I'll get spring constant is 2000 multiplied by, in calculation, you should never put the SI unit along with the magnitudes. And why is it so? Because at this level, if you put the units in the calculation, then you have to do the calculation of units as well. So that is out of the way. That is beyond your limitation right now at this particular level of matriculation. So 2000 multiplied by 2000 spring constant, the magnitude of spring constant varies. This magnitude of spring constant multiplied by the change in length in the second situation. The change in length I have written in the given data in the second situation is 16 millimeter, and it is in meters is approximately 0.016. So in this particular case as well, I have substituted the value of milli, which is 1 milli is equal to 10 to the minus 3, and I have put on the right hand side the standard reference as well for the sake of simplicity for the example. So you should never forget to write it down here on the right hand side where you have substituted, where you will substitute the value of milli in your final exam. So the value is 32 Newton. So the weight of the second object is 32 Newton as I predicted, depending on my concepts in the previous part of the video as well. So if you have any query, if you have any problem, then you will ask me about that particular numerical. So I'm going to read the statement of the numerical, which is 6.2. The examiner said the mass of 5 liters of milk is approximately 4.5 kilogram. Find its density in SI units. So, density, what is meant by density? Measurement of the extent of compactness or closeness of the particles of the object or substance or matter within the given region of internal spacing, which is called volume of the object. So measurement of the extent of compactness, which is defined theoretically on the basis of conventional definition of Hooke. Theoretical books or bookish language. In bookish language, I can say that the density is defined as mass per unit volume, or technically speaking, it is defined as the measurement of the extent of compactness of the particles in the given region of internal spacing, which is called volume of the object. So its formula, which I derived in the previous class, is density is equal to mass per unit volume, or mass is in the numerator sigma m total, or simply m, which is a symbol of mass of the object in the numerator and volume of the object in the denominator. So in this case, the given data is mass of 5 liters of milk. Now, what is this mass of 5 liters of milk? That's the mass of the object, which is the interpretation of the mass. The steps to write given data. First of all, you have to write the interpretation. Then you should write the symbol which is used to denote the physical quantity in that particular record. And after that, you have to write the number, the numeric figure with the examiner written, with the examiner wrote, or with the examiner write in the situation of the numerical, which is 4.5. And if the unit is not in SI, so you have to convert the unit from any particular system, which is FPS or CGS, to the system which is SI, which is MKS. So that is the theoretical domain. These are the conventions, these are the rules to write the given data. So mass of 5 liters of milk is equal to small m, that is equal to 4.5 kilogram. Okay. Now what is the volume? The volume of the milk is 5 liters. No, liter is not S liter is liter. The SI unit of volume, what do you think? I don't think so that liter is the SI unit of volume in SI system. The unit of volume is meter cube. So as I know, 1 liter is equivalent to 10 to the minus 3 cubic meter or meter cube. So I have written a standard reference, and by substituting the value of liter, 1 liter in 5 liters, the 5 liters will be converted into cubic meters, which is 0.005 meter cube, or 5 multiplied by 10 to the minus 3 meter cube. So I have to calculate the value of density of milk. The density of milk is, I have to write a symbol which is rho. I didn't write the symbol, so wait a minute. I have to insert the symbol of density. I have to insert the symbol of density. So that is the symbol of density is rho. That is rho. That is the 17th letter of 17th Greek letter, 17th alphabet of the Greek language. That is rho. That is not capital P. That is rho. Okay. So using mathematical relationship, density is equal to mass per unit volume. Density is equal to mass per unit volume. Density is equal to mass per unit volume. So after substituting Okay, after substituting, we're putting values. Mass is 4.5 kilogram. The volume of the object is 0.005. So after solving, mass is 4.5 divided by volume of the object, which is 0.5 multiplied by -3. So the computated value of the density of the milk is 900 kilogram per meter cube or cubic meter. So that can be written in the standard scientific form, and the standard scientific form is the power of 10 should be multiplied with the number which should lie between 1 and 10. So by shuffling the decimal point from the right hand side up to 2 decimal places to the left hand side, the value will become 9.0 multiplied by 10 power plus 2 kilogram per meter cube. So if you have any query till now, you can ask me in the group or through personally. Jazakallah. अपना ख्याल रखिएगा. टेक केयर. अल्लाह हाफिज.